Well, hello and welcome to another edition of Quarantine Science with Mr. Oldhouse. As you can see, we are on day something or another. We've all lost track now, but we are in our quarantine still, but we are still learning. Today, topic of conversation is going to be writing covalent bonds when you're not given a formula for them. So for example, if I give you carbon and bromine, I say create a covalent bond between carbon and bromine. And you know it has to be covalent because carbon is a nonmetal and bromine is a nonmetal. Well, there's a couple ways that you can do this, but we're going to focus on the most simplistic way. Okay, we're going to look at how do we figure this out. Okay, now the hard part about covalent bonds is they can form in a lot of different ways. So I'm just going to show you the most simplistic one today, the one that we're going to be talking about most in our physical science class. As you get into chemistry, you can start talking about how they take on a positive charge or a negative charge and all of that stuff. We're not going to get into that today. Instead, we're just going to look at how you create it specifically. Also, as you can see, I'm in my new set with my shiny new helmet over here, and I got Woody Hayes and Terry Francona and Coach Tressel, and then of course we're in quarantine, so I have my toilet paper and Clorox wipes just in case. I mean, we bought a ton of toilet paper. I have no idea why exactly we needed the toilet paper. But we have enough now, so we have plenty. So let's go ahead and jump right into it. Let's look at carbon and bromine. Now, when I'm looking at carbon and bromine, when I start to do this, get out my trusty whiteboard here, and when I do that, I want to draw the Lewis structure for them. Okay, so if I'm looking at carbon plus bromine, all right, so I have carbon plus bromine. Okay, so I have carbon plus bromine. Now, as I do that, I want to write we're going to focus on the first one, carbon. We're going to put our C here, we draw a Lewis structure for it. 1, 2, 3, 4 total dots. Now, I didn't give you a formula, so I don't know exactly how many bromines I'm going to need, okay? So let's go ahead and draw a single bromine out and look at its Lewis structure. Okay, so I draw my BR here. I know the bromine has 7 valence electrons, so I go ahead and draw that Lewis structure in there, and I put my dot there. Now, the goal is the octet rule. So we want to get to 8. So as I look right here, I make that circle, okay? And I ask myself, is this bromine happy? Well, it's got 1, 2, 3, 4, 5, 6, 7, 8. Sure it is. But is the carbon? Well, the carbon's got 1, 2, 3, 4, 5. Okay, it's underwhelmed right now. It needs more. Okay, it's just that single bromine's just not enough. But let's go ahead and let's draw our bond in there. All right, so there's our straight line bond. Okay, we draw that in there. So now we show that single bond. Well, let's go ahead and do another one. I'm going to put a BR down here. BR, 1, 2, 3, 4, 5, 6, 7. Let's take a look again. Go ahead and make that bond between the two. Is this bromine happy? Well, sure it is. It's got 1, 2, 3, 4, 5, 6, 7, and 8. Is this carbon? Nope, still. There's 1, 2, there's 3, 4, there's 5, and 6. It needs 8. It's got to get to 8. It wants to get to 8 according to the octet rule, so I add another bromine over here. I do the same thing with my 7 valence electrons. I draw those in. I show that bond right there. Now I have 1, 2, 3, 4, 5, 6, 7, 8 for bromine. It's happy. It's good to go. It's loving life. This carbon, though, is still left unsatisfied. It needs one more. Okay, it needs to get this electron up here paired. So we're just going to draw in another BR up here. 1, 2, 3, 4, 5, 6, 7 valence electrons. Oh, I need to put I'm going to move this down for carbon. 7th valence electron in, draw that straight line to show the bond. Okay, so now I have 1 bromine, 2 bromines, 3 bromines, 4 bromines. So when I want to write out the chemical formula for this, I simply put C. I only have 1 of them, so I don't need a 1 down here. That would be ridiculous. We don't do that. But then I have 4 bromines, 1, 2, 3, 4 bromines. So I put my BR here, and I put my 4 down below. That's how you go ahead and do that. Pretty straightforward, pretty simple. You want to make sure that everybody has 8. Carbon has 8, bromine has 8, all the bromines have 8. We're good to go in that situation. So that's how you set up that problem. It's going to be the same thing for whether you're using like nitrogen and fluorine, okay? Oxygen and carbon, same kind of idea, okay? This just happens to be a single bond, and I know it's a single bond because I only have 1 line. If I were looking at carbon and oxygen, we all know what that is. Okay, carbon and oxygen is CO2, so we all know what that's going to look like. Plus O, X, Y, G, N. All right, so I have my carbon in the middle. Again, 1, 2, 3, 4. I'm going to put an oxygen over here. 1, 2, 3, 4, 5, 6. Now here's the key on this one. This is actually going to set up as a double bond. I want these two, and I want these two. Same thing over here with my oxygen. 1, 2, actually let's do this. 1, 2, 3, 4, 5, 6. I have a bond here, and I have a bond here. Everybody in this situation is happy, okay? Everyone's good to go. We just have our double bonds now here instead of a single bond. So if I were to write this a little bit more proper, a little bit of way that we want to actually see it written Lewis structure-wise in science, it's going to look a little bit more like this. Have my double bond here, double bond here, okay? Where you put these dots is eventually going to matter. Right now, we're just putting them there. A lot of times you're going to see them written as this, which is also okay. Kind of up to you. Down the line, it's going to matter. Right now, we're just going to go with this, okay? So that's one of the things that we were going to talk about today. The other thing that we wanted to talk about today is I wanted to show you one of those extension problems and kind of how to answer it. Okay, so when I look at this, we're looking at this formula. This time we actually give you the formula. So it's C2H4. Now, trick with carbon. Okay, trick with carbon is you always want to kind of keep them together. Carbon's going to love to bond with itself. So I'm going to put my carbon here in the middle. I'm going to put my carbon here in the middle. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now I know I have 4 hydrogens. Okay, so when we go through and do this, you want to figure out where those 4 hydrogens are going to fit in. I can't bond them all to this carbon because this one's not in play. Okay, I can't bond them all to this carbon because then this one's going to be left all alone and unsatisfied. Okay, so what I want to do is I'm going to take 2 hydrogens and put them over here. So I have a hydrogen here, I have a hydrogen here. We know hydrogen has 1 valence electron on each, so I'm just going to go ahead and set it up like that. I'm going to go ahead and show the bond here between these guys. Now that hydrogen is happy. Do the same down here. Share those electrons. Now this hydrogen's happy. Let's go ahead and do the same thing to the other side. Let's put our hydrogen here. Let's put our hydrogen here. We have our 1 valence electron, 1 valence electron. And let's go ahead and do the same thing. Let's look here. These two, let's share them. So this hydrogen is now happy with its 2 valence electrons, and let's go ahead and share these guys. And this hydrogen's now happy with its 2 valence electrons. But let's look at the carbons. This carbon right here on this side has 1, 2, 3, 4, 5, 6 valence electrons. Is it going to be happy in this situation? Answer is obviously no. So it needs to figure itself out. It needs to figure out how to share these other 2 electrons to bring in 2 more. This carbon over here, let's look at it. 1, 2, 3, 4, 5, 6. It's not happy either, okay? And the other problem is too, we have basically 2 different things going on over here. We have this carbon over here all by itself, this carbon and hydrogen all over here by itself. Let's merge them together. Let's bring them together. We do that by sharing bonds between the carbon. Go ahead and share that bond here. Go ahead and share that bond here. And what we get is we get a carbon right here. I'm going to try to go through this so you can see it. Carbon right here has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Same exact thing's happening on the other side. This carbon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Everybody's happy. Now we're going to take this and actually turn it into something that looks a little bit cleaner and looks a little bit nicer. So let's go ahead and do that now. Okay, we have this, so we know what it looks like. We know how to draw it. Let's make it cleaner. So we have C2H4. So I go ahead and put my 2 C's in the middle, put my H's on the outside over here. And then all we need to do is draw our shared pairs. The line represents the shared pair. So I have a shared pair here, I have a shared pair here, I have a shared pair here, I have a shared pair here. Those 4 lines, okay, represent these 4 lines on the outside. Represents 1, 2, 3, 4. I still have to represent my bond between the 2 carbons in the middle. So I'm going to go ahead and do that right now. And all that is just 2 straight lines. It's a double bond between carbon in the middle. And there you go. Everybody's happy. You've created C2H4. Okay? And we're going to talk about how we say that name properly as we start getting into nomenclature in our next video live from Mr. Aldhouse's quarantined house and his newly established YouTube studio, which makes me an official YouTuber. I don't know how you make money off of it. I have not seen my bank account increase at all. It would be awesome if that happened. It hasn't. But being an official YouTuber now / teacher, I'm feeling pretty good about myself. Okay, feeling pretty good about myself. Thanks for tuning in. Thanks for checking it out. My class, continue to work through this. If you have questions, email me. If you have any comments, email me. If you have anything you need me to go over, you want me to go more in depth to, email me. It is going to be Wednesday, April 1st, April Fool's Day. Yes, my favorite. Boo! Oh, sorry. Did I get you, Sajida? Probably did. So it's going to be Wednesday, April 1st when you watch this. So enjoy the day. Have some fun. Try to make the best out of your quarantine life and make sure you got your TP ready. We don't know why, but make sure you have it ready. Have a great day, guys. I'll see you later.